be a quick review of inverse and joint variations because I tried to record this like 5 other times and it was way too long before, so I'm gonna try to make it short. Okay, so I'm gonna review all of this based on chapter 8.1. So I'm gonna be explaining what each type of variation is, how to recognize it, and how to solve problems using these formulas. Okay, so first of all, what is variation? What even is this? So in math, variation means how one quantity changes in response to another. There are three main types. You have the direct variation, which you should know by now. That's when two things grow or shrink together. Then you have the inverse variation, where one goes up and the other goes down. And lastly, you have the joint variation, when a variable depends on multiple others multiplied together. It's a bit of a tongue twister, but we'll get to that. Here are also the formulas, which I'll be discussing um, in their own separate slides. So first we're going to look at the inverse variation. So the inverse variation basically means the variables move in opposite directions. So the formula for this is y is a divided by x. That a right there is constant. So that is a constant. It doesn't change. So let's say, for example, y is 6 when x is 2. If you can do basic math, that means a has to be 12. So we write the equation y equals 12 over x. Now, let's say x becomes 4. Then y will drop to 3. See how when x increases, y decreases? That is the inverse variation. And graph-wise, this looks like a curved line, a hyperbola, with the asymptotes at x equals 0 and y equals 0. So next we have the joint variation. The joint variation is when one variable kind of depends on depends on a combination of others multiplied together. So the basic formula for this is z equals a times x times y, or sometimes with more variables, but I'm not going to discuss that because I'm not going to discuss that. So here's an example. Z is 1200 when x is 3 and y is 10. That gives us a equals 40. Now, if x is 4 and y is 6, just plug those in. If you do the calculations, z equals 40 times 4 times 6, which is, anyone? 960. So, I'm sorry, I'm kind of sick. Joint variation is like stacking values. More variables means more output. Now, we are going to do a quick comparison. So, if you paid attention, you would notice that inverse uses division. One thing goes up, the other goes down. Joint uses multiplication. Everything grows together. And the key is in the wording. So, if a problem says inversely with x, it means divide. If it says jointly with x and y, it means multiply. So, let's finally do a real world example. Say the strength varies jointly with width and the square of depth. So our formula is S equals 8 times width times depth squared. So, I'm sorry, I am really sick right now. If strength is, oh my god, if strength is 1200 when width is 3 and depth is 10, we get 1200 equals 8 times 3 times 100. That makes a 4. Now with width 4 and depth 6, we calculate S equals 4 times 36, which is 576. Yes, just did that all in my head because I'm just built like that. So, a summary of the things I discussed today. Here's kind of like what you should take away from this lesson. If you see inverse variation, think division and opposite movement. If it's joint variation, think multiplication. Everything's connected. Always find A using the values they give you, then plug in new ones to solve. The trick here is reading carefully and knowing which formula fits. So, yeah, guys, that's it. Hope this helped making inverse and joint variation a little more clear. It certainly helped me because I am a great teacher. Thanks for watching, guys. Bye bye.